Okay, so your warm up, you have circle T. List 7 things you can conclude about the figure and how is angle ACB related to angle ATB. Here's what I got. See if I can zoom in on that just a smidge. How's that better? So these are just the things I found. As you can see, I'm also using a lot of different colors here. Something like this, having colors does help. Pack of highlighters, colored pencils, erasable gel pens, things like that. It definitely could not hurt to have those things. Okay, if you only got some of these, but not all of them, here's the information for you. You can write it down. All right. I'll give you a few minutes to just check this over. Show of hands who's still looking at this. Okay, so let's write down some information. So it says the first thing we have is what is an inscribed angle? And it's an angle whose vertex is on the circle and whose side each contain chords of the circle. So if you look right here, this is an example. So this would be an example of an inscribed angle. It doesn't go through the center, okay, but it does intercept an arc. Okay. And I'm not going to say it's going to be directly opposite the arc because technically the chords can go over here, over here, over here. Okay. But just know that it does go, these chords hit somewhere on the circle that is not with the intercepted arc. Okay. Now, the next part we have is if an angle is inscribed in a circle, meaning meaning the vertex is on the circle, then the measure of the angle equals half the measure of its inscribed arc. So if this was 50, this would be 25. We also have this corollary right here. Two inscribed angles that intercept the same arc are congruent, which would make sense. Okay? And that would look, you do not have to write this down. You're going to get an example of this, providing this actually lets me. But it would look kind of something maybe like this. Okay? See how those two intercepted angles hit the same arc? They would have to be congruent because the rule still applies. Okay? Questions on this? Okie dokie. Let's get into our examples. So again, colors always help me to kind of identify, but like I said, this isn't hard. It just can be a little visually challenging. So I always like to highlight things so that I know what I'm looking at. So it says find the measure of angle X. So here's W to X to Z. This is that intercepted arc. So that means that I am going to have 1/2 of 58 degrees, which leaves me with a total of 29 degrees. Now, they want the measure of angle y. So here's angle y. It intercepts the same arc. So again, it's half of 58, or you can just state that, angle x is congruent to angle y. So the measure of angle y is 29. Now, what do you notice about parts A and B? The angles intercepted the same arc. Okay. Any questions on this? All right. Given circle C with diameter AR and the measure of HCA equals 50, find each of the following. So let's see, we got measure HCA. So we know this right here is 50, which makes HA also 50. So I'm just kind of labeling things that I already know. I have RCH, this angle right here. Now this is a diameter, so this is 180 degrees, which means this would be 130 degrees, and this would be 130 here. Now, I know I have 180 degrees left here, so I know this is 180. This whole thing should just equal, well, why does it look like a 9? Sorry, that's supposed to be a 0, guys. My apologies. There we go. All right, so let's see what we can find here. So we have HIA. So here is H to I to A. So HIA is going to be half of 50, which gives us 25. We have H to C to R. We found that. That was 130. HIR. So H to I to R is intercepting this arc. So it's half of 130, which is 65 degrees. And then lastly, we have AIR. So A to I, let me get a different color. Sorry about that. That's not pops. A to I to R, and it's intercepting this whole arc. Now, this is a semicircle, so this whole arc is 180 degrees, which makes this angle what? 180 divided by 2 is 90. So what conjecture? Write a conjecture about inscribed angles on the diameter of a circle, okay? So in angles inscribed in a diameter equal right angles. So the corollary is if an angle is inscribed in a semicircle, then it is a right angle. So the thing I want you to notice here is if we have this diameter and this, we end up having a right triangle there. So if those two chords intersect at a diameter, we have a right triangle on that semicircle. So maybe the Pythagorean theorem is going to apply. Okay. Any questions, comments, concerns, Snyder marks? No? Okie dokie. Let's move on then. Flip the page. All right, so it says here's another corollary. The opposite angles of an inscribed quadrilateral are, in this case, supplementary. So given circle Q, it says find the measure of angle K. Well, measure of angle K is directly across from this 49-degree angle. So we're just going to take 180 minus 49, which gives us 131 degrees. They want us to find the measure of MJ. So here's M to J. Now, if we look at this, all we need to do here is figure out what this is, and then we can find out what MJ is. Now, this LMJ is an inscribed angle. So which means if this is 49, arc L to J is what? We're going to take this, multiply it by 2, which gives us... It's 49 times 2. 98. So from here to here is 98 degrees. So in order to find this, we're just going to take 360 minus 120 minus 98. So we should get a total of 194 degrees. That's for MJ. Questions on that? All right, so now it says find the measure of KJM. So here's K to J to M. All right, so what do you guys notice about KJM? Is it an inscribed angle? Yes, no, maybe so? What do you guys think? Is it an inscribed angle? All right, well, let's think about it this way. What about this guy? What about KLM? Is that an inscribed angle? Do we have two inscribed angles here? Yes or no? Yeah, we do. So we can do this one of two ways. We can find this angle, and then we know it's supplementary to this. Or if we look here, this is completely inscribed. Thank you. Yeah. Enough. Where are you? Sorry. There you are. Oh. Okay. Okay, so what I'm going to do is I'm looking at this. I got 120 plus 46, which leaves me with 166, right? I divide that by 2. What do I get? What happened? What do I get? 166 divided by 2 is what? 83. Okay. Questions on that? You okay? Everything okay? Yeah. Okay. All right, let's move on to example 4. All right, so again, remember, these are slowly getting a little more complicated, so colors help. If circle F, in circle F, we have that the measure of arc WX is 20 degrees. The measure of XY is 40 degrees. U to Z, so this entire thing right here, is 108 degrees. And arc UW is congruent to YZ. Find the measures of the numbered angles. All right, so before I do that, I want to find these two arcs. So I have everything I need before I move on. Okay. So in this case, I'm going to take 360, I'm going to subtract 20, I'm going to subtract 40, and I'm going to subtract 108. This leaves me with a total of 192 degrees, and since both these arcs are congruent, I'm going to divide them by 2, leaving me with each arc being, I got 96. I'm going to erase this because we just got a little too cluttered. So I have 96 here, 96 here. Okay. Now that I have that, let's take a look at the measure of angle 1. Oh my God. Here we go. All right, so the measure of angle 1 is right here. It's inscribed with the arc containing 96, so I'm going to do 1/2 times 96, which gives me 48. The measure of angle 2, right here, it's intersecting the 40-degree arc, so 1/2 of 40 equals 20 degrees. Everybody with me so far? Any questions? All right, the measure of angle 3 is right here. That's intercepting this arc, so we're going to have 1/2 of 108, which leaves us with 54 degrees. Now for the measure of angle 4, if we look at it, it's right here, but we're inside this triangle. And we have the measure of angle 3 and the measure of angle 2. Remember, 2 was 20, 3 is 54. So we're going to take 180 minus 20 minus 54 degrees, which gives us a total of 106. Everybody with me where that one came from? And then next, if we take a look, here's angle 5. We are intercepting the same arc as angle 3. So for the measure of angle 5, sorry, not 3. 5, we can state that the measure, or not the measure, but we can state that angle 3 is congruent to angle 5, so the measure of angle 5 is equal to 54. Or, again, 1/2 of 108, either way works. Do you guys kind of see how colors can help a little bit? I mean, if you're like this, like draws over when I'm done with something. If you're the type that really needs something clean, use something erasable. Okay, just a thought. Like erasable gel pens work good, erasable colored pencils, what have you. Questions? All right, let's move on to example 5. So here's our next theorem. It says the measure of an angle formed by a tangent in a chord is half the intercepted arc. So they want us, all we're doing here is we're just doing a little bit of a discovery. So if we have that line RP as tangent circle X, what is the measure of X to P to R? Well, in that case, it's 90 degrees because we remember that this is a diameter or this is a radius, and remember the radii are perpendicular to the tangent line. And also recall it says, what is the measure of arc YZP? So Y to Z to P, remember this is a semicircle because of this diameter. That's 180 degrees. So what we discovered here is the tangent chord theorem, okay? And we have it in words, but what this is saying is that if we take half of that arc, we get the angle. Question so far? Okay, number 6. It says given line BD is tangent to P. Now this is not a radius, it's just a chord, so it is not necessarily perpendicular. At point C, if the measure of arc A to C, so this arc right here is 88 degrees, what is the measure of A to C to B? So they want this one right here. That's going to be half of 88, which gives you 44 degrees. Given EG is tangent to circle P, at point F, if the measure of angle GFC, so G to F to C, so we have this whole angle is 115, what is the measure of F to A to C? Now we can find everything right here, F to A. No, wait, I'm sorry. Never mind. Scratch that. We have this angle and we have this entire arc. This is tangent, which means this whole arc is going to be 2 times 115, which leaves us with 230 degrees. And then when we talk about the measure of F to C to A, we need to find kind of what's left here. So we're going to take, first off for this, 360 minus 230, which gives us a total of 130 degrees. And then we're going to take 130 and add, so this is going to be 130 plus the 88, giving us a total of 218 degrees. Questions on this? Okie dokie, artichokes. That is it. Get going on your homework. Those of you watching at home, have a great day.